Good morning, students. I trust we are all doing well. So we are continuing with the financial mathematics on the financial mathematics. So this time around, we want to look at amortization and sinking fund, especially, and then where we have perpetual investment. Okay, so amortization, as we did it, we got to know in our previous lecture. Amortization concerns the repayment of a loan by equal annual installments at equal intervals of time. So normally it is the principal, that is the loan that you have taken, which is spread over a period, right? And for all you know, you are making equal installments at regular intervals of time in order to finish paying the loan. But each installment is made up of two components, that is the principal and the interest. So if you can split the principal, that is the installment, into principal and interest, then we can prepare a schedule to show how the loan is being repaid. So sometimes people say that that is the cheapest method of advancing a loan to people. That is not. It is the ideal way, because in actual fact, if you have taken a loan, you see, and you are to pay it by equal annual installments, let's say 5 years. And then at the end of the first year, you did not default, but you made your payment, you've made your installment. Then the interest must not be calculated on the original principal, but then on the outstanding balance by deducting the installment you have paid from the principal. That is, the installment is made up of the principal and the what? Interest. So when that is deducted from the original principal, then the interest will be calculated on the outstanding balance. So you can see that whilst you keep on paying, if you are splitting the installment into principal and interest, you see that the interest will be reducing while the principal is increasing. So that is the ideal way to go, but it's not that it is the cheapest approach. Well, we only say it is the cheapest approach if you are not making a one lump sum payment. You see, because that's another form of repayment. You can take a loan and the money will be with you for the duration that it's supposed to be with you. So you are not making any payment until the final day. And that day you are to pay the full amount and the interest that has accrued on it. You see, okay. So when you are making equal installments over a period of time, in order to finish paying a loan especially, then that is amortization. So that is an annuity. It comes under annuity. The same applies to sinking fund. Sinking fund is where you are setting equal amount of money aside and then investing in a fund. Maybe a company can do this in order to expand its production capacity or to introduce a new product. I mean, it depends on what you want to use the money for. So it's all about investing to raise a capital. Okay, so let's look at what we have. And I think we have done most of this before. What we are seeing in the first slide is just the amortization that we compute, the various schedules. We have payment in advance, and then we have payment in arrears. For example, if you have gone for a loan and the loan is being repaid, the installment you are going to make, you are to pay it in advance. That is, advance means you are paying at the beginning of the period, at the beginning. Then the formula will be like this. So let me just take a new slide. The formula will then be like this. So it's just about you knowing which formula to use for which problem. You see, so the principal is a P, and then the small a here that I'm writing is the installment you are making. Okay, so if you are making payment in advance, then you're going to have a formula like this. So 1 plus R. So 1 plus R. 1 plus R, okay. And then all multiplied by, into brackets, 1 plus R. So 1 plus R. All raised to N. So all raised to N, where N is the duration of the loan. And then all minus 1 all over, and then R, 1 plus R, 1 plus R, all raised to N again. Okay, so this is the formula for advance payment. You see, but that does not normally occur, because if you are asked to pay in advance, then it suggests that you are making a deposit. You see, because that one, it is year zero. The time that the money was given to you was the time that you must make this payment. So normally when we take a loan, we start paying at the end of the period. So if it is in arrears, and arrears is at the end of the period. You see, just as salaries are paid, so your small a is the installment. If it is at the end of the period, then this will be your formula. Of course, you can also use the formula in the slide. Okay, because so that is 1 plus R raised to N, all minus 1 all over R, 1 plus R raised to N. So let me write it. Okay, so raised to N. You see, and you should take note that this formula can also be written like this. It's the same as this formula. P is equal to A 1 minus 1 over into brackets 1 plus R 1 plus R raised to N, and then all over R. So the formula can be written like this. Okay. It can also be written like this, P, and that is the one I like using. So P will be equal to A, right? And then 1 minus 1 plus R, so 1 plus R, and then raised to negative N. If you want that is if you want 1 plus 1 over 1 plus R to stand alone, then all over R. So this is another. So that is for amortization. And we can prepare the schedule, right, for advance payment or for arrears payment. But for amortization, in most cases, what happens is that payment is made in arrears. Okay, so let's look at Let's look at the question that we have. Let's go back to the slide. Okay, so this is a another formula that you can use. So this is A is equal to P times I, or multiply by, that is if you want to find the installment. See, the installment that you're supposed to pay. If you want to find that, for example, this one, this is P is equal to this, right? So if you want to find A, which is the installment payment, so normally the safest way is that you substitute these figures. So you know the principal, that's the loan you have taken, and then you know the rate of interest, you know the duration, and you see, so you just substitute for the P, which is the principal amount. You also substitute for the R, which is the rate of interest. You also substitute for N, which is the duration. And then you get all this one on this one on the right hand side, with the exception of the A. All this will give you what we call the annuity factor. The annuity factor. So at the end of the day, it will be A multiplied by a certain figure here. So if you have something like that, then A is what? P over that figure, or you get here. That's all. Then you go your way. Okay, so let's go back to the slide. I think there is a question there. And let's look at how we go about that. Okay. So this is a formula that has been given. You can also use this formula, but you can also use what I've also specified. Okay, so this one is also about the schedule. But let's look at this example. We say that a debt of 10,000 with interest of 5% per year is amortized by equal annual payment over the next 6 years. You see, so find the value of each payment and then construct an amortization schedule. Okay, so let's see how this can be. The principal amount is 10,000 and the rate of interest is 5% per annum, and the duration of payment is 6 years. So first of all, we need to determine how much we are to pay every year. And when the question is silent on whether payment is made in advance or in arrears, then we take it that it's in arrears. So this one, for example, payment will be in arrears. If payment is in advance, the question will clearly state. Okay, so let me rub all this quickly so that we continue. Okay, I think I'm rubbing. Wow, it's not. My friend. Okay, so let me take this one off quickly. So that's the only disadvantage of using the, obviously it has not been designed for writing several things. That is how it is. So you need to just take your time. So patience for this. Okay. All right. So the principal P is 10,000. So 10,000. That is 10,000 cities, right? and then the rate of interest R is 5%, so 0.05. So 0.05, and then the duration N, well, it's using T, okay, but if I'm using N, it will be 6 years, okay, 6 years. So if I'm using this formula, P, using this formula, then it says a straight thing. It's very simple, right? P will be equal to the small a, and then because payment is in arrears, so note that you have to quote the formula for the arrears. Okay, so 1 plus R raised to N. So 1 plus R raised to N, all minus 1 over R, and then into brackets 1 plus R all raised to N. So this is a formula you need to quote. Also use what has been provided in the slides. It's not a problem. So here you have 10,000. I'm substituting for P. So P is 10,000. To even go, there's another matter. Okay, so, and then A. So A is what we are looking for, the installment. So 1 plus 0.5 will be 1.05. Just want to make it. So 1.05 raised to 6, or minus 1 over 0.05 multiplied by 1.05, so 1.05 all raised to 6. So sorry for. Okay, so when you compute whatever in the bracket, you're going to have, so this will give me 10,000. So 10,000 equal to A. So you compute whatever is in the bracket. A multiplied by all that is in the bracket. And when you compute that, 1.05 is to -6. 1 minus that. So okay, so that will give me raised to -6. 1 minus that. So 5.07569. So 5.075. Okay, so 69. So that A will give you, A will be equal to, so that will be 10,000 over that. Divided by that will give you 1970. So 0.70 0.17. Okay. So what it means is that if you have taken a loan of 10,000 from the bank and the rate is 5% per annum, which you won't get, which it doesn't exist, but this is just for learning purposes, and you are to make repayment for 6 years, and that is annual equal installment for 6 years, then this is what you'll be paying every year for the next 6 years. So if you want to know the interest on the loan, then it is just multiplying the 1970 by 6, because you are making this equal payment for 6 years, every year for 6 years. So when you multiply by 6, you see the total amount you would have paid at the end of the 6th year will be 11,821. You see, but you took how much? 10,000. So it means that when you less the 10,000 from the 11,821, then the 1,821 will be the interest that you have paid on the loan. Okay. Now, we are asked to demonstrate this in a tabular form. Of course, if you are to prepare an amortization schedule, then it's a matter of demonstrating your schedules in a tabular form. So now, normally we have about 5 columns. The first column will be the years, and the second column will be the principal amount. The third column will be the interest on the installment. Let's split the interest into principal and so let me do this. Let's see. So this is the schedule. So we have 5 years. Okay, so let me write. So this is the year. So year, YR. Year. And this is the principal amount. See, principal. So the years is up to 6 years. So 2, 3, 4, 5, 6. Okay. The principal is 10,000. So you bring your 10,000. 10,000. Okay. And this is the interest column. So let me just write so R is equal to 5%. 5%. So when you have calculated the interest, then you add the interest to the principal. So this will be the total amount to pay at the end of the year, because it's in arrears. Okay, but if you want to split the installment, which is this, so installment, I'll just write in INST, which is equal to what? A. Okay. So the installment, I want to split it. I'll just bring the principal here, right? Because I'm splitting, and then this will be the balance at the end of the year, each year. So BAL, the balance that you are owing or outstanding balance. Okay, so in the first year, the principal is 10,000. So when you calculate, it means at the end of the first year, you are to pay 5% of the 10,000 as interest. So that will be 500. 500. Okay, so the total amount that you be owing will be 10,500. You see, now if at the end of the first year, which you are supposed to have paid the interest, and you default, then the second year the interest will be calculated on 10,500. But if you are able to pay, if you pay your installment, which of course in this case is 1970, right? So this one you are making this equal installment. I think it's 1970. Let me point 1.05 all raised to -6. 1 minus that divided by 0.05. 10,000 divided by that will give me 0.17. Okay, so we'll make it 0.1746. So 0.1746. We are taking the 4 decimal places. Oh, let me erase that. Sorry. Okay, so you are paying equal annual installment of, you are making equal annual installment of 1,970.1746. So you are making this, so you write this 6 times, so 1,970.1746. So 1,970.1746. So the last two 1912. Okay, 1,970.1746. And then the last one 1,970.1746. So here, when your interest is 500, you less it from, so we less the first interest. So the principal here will be 1470.1746. But your total loan at the end of year one was 10,500, and you are making an installment of 1970. So 10,000 minus 1970.1746. So the balance will be 8,029.8254. So 8,029.8254. 8254. In fact, right. Okay, so that will be the beginning balance from the beginning of the second year. So 8029, 8029.8254, 0.8254. You see. So at the end of the second year, the interest should be computed on this and not on the 10,000. So multiply by 0.05. So at the end of the second year, our interest will be 401. So you see that the interest is reducing whilst we make our installments. So 401.4912, 4912. So when we add the interest to the principal, so plus 8029.8254, 8254. Okay. So that would be 8431. 316, so 8431.316. So 3166. Okay, so then we pay our installment. So we less 1970.1746. So the balance will be 6461. So the balance will be 6461. 0.1420. 1420, or we can make it 21, no problem. So that will be the beginning balance from the third year. So from the third year, the balance is 6461. Note that if you have to separate this, the 1970 that you have paid for the second year, and you less the interest component, which is the 401.4912. Then the principal will be 1568. So you see that while the interest is reducing, the principal will be increasing. So here the principal will be 1568.6834. So 6834. Okay. You see, so this is a balance. So 0.1420. Okay. 142020. So now the interest will be calculated on this. So that is 6461, sorry, 6461.1420 times 5%. See, so that will be 323.0571. So 323.0571. So when we add it to the principal, so plus 6461.1420, that will be 6784. So 6784.1991. Okay, so 1991. You less your installment, assuming you have paid. So 70.1746. So the balance will be 4814. So here 4814.0245. So 0.0245. And again, if you less the interest from the installment, so the interest is 323.0571. So 1970.1746 minus 323.0571. So the principal will be, is 1970, right? Okay. The principal will be 1647.117. So 1647.1175. Okay. So our balance is 4814.0245. So the interest will be computed on this. Okay, so 4814.00245. Okay, and then 5% of it, so times 0.05. So that will be 240.7012. So 7012. Okay. So the total amount will be this plus the principal, which is 4814.0245. So that will be 5054.7257. Or we just take the 4 decimal places. So 7257. Wow, the writing is okay. So less our installment. So minus 1970.1746. That will be 3084. So 3084.5511. 5511. So that will be the opening balance for beginning of year 5. So 3084. So 3084.55 84 11 rather, right? 11. Okay. So we find the interest. So multiply by 0.05. That will be 154.2275. So 154.2275. So when we add it to the principal, that will be 3084.5511. That will be 3238.7786. So 7786. Then we less our 19. Okay, that's minus 1970.1746. To be left with 1268. 1268.6040. Okay, so this one, the interest will be, the principal here will be 1970.1746 minus the interest, which is 240. So 240.7012. Okay, so the principal will be 17. The principal will be 1729. 729.4734. So 4734. And here too, 1970.1746 minus 154.1275. So the principal will be 18.0471. Okay. So here our balance is 1,268, right? So 1268.06, sorry, 6040. So 6040. We find the interest at 5%. That will be 90,802. So 90, wow, 802. This will give me the plus 1268.60. It's not giving me. Yeah, I think I've lost something. There is something that probably I've missed. Let me see. One, two, three, four, five, six. Oh, you see, I made a mistake for the first one. Wow. It's supposed to be 8529. Oh, and I wrote 80. Okay, so I'm sure when you do all the checks, I can't go over. So it's supposed to be 8529.8254. So how come I wrote 80? So this one too must change. It means everything will change. You see one of the, and it's even good I've made this mistake so that when you are doing it, you be very careful, because when you write something wrong, it's going to affect the whole thing. So this should be 8529. It means when you compute the interest, it will also change. So the interest will also change from 401. Change. So this multiplied by 105. How come? So 426. You see, 49. Okay. So this will be 426, not 401. So 426.4912. So when you make those changes, this will tally. All right, so let's go back to the slide. Let's go back to the slide, right? So okay, so as we go 1970.17, okay. And then this is a schedule you can go through. Now let's come to sinking fund. So like I was saying, sinking fund is about investing. That is, so let me go back to the whiteboard. So sinking fund is about setting equal monies aside, right? And paying into a fund. For example, when you look at deduction of workers by SNIT, if the amount that is being deducted is constant, is the same every month, then that is a typical example of sinking fund, because the monies are being invested, they are paying to a fund for your retirement. So that's a typical example of sinking fund. Okay, so look at, and that one too, we pay both in arrears and in advance. Okay, so I'll just quote the formulas for you. And as I've been saying, unless you have been asked to derive the formula, you are not supposed to derive. If you have been asked, then you do it. So all you need to do is to read the question, make sure you understand the question, know the formula that is applicable to the question. That's all. Remember that this one, the annuity factor, we also have annuity tables that we can read it straight, but I cannot show you because unless I show you the table. Okay, so there is also a table for sinking fund. We have for the advance and we have for the arrears. There's also a table for future value for single sum of that is one bulk sum of money that you want to invest into a fund. See, so we can just determine the annuity factors from a table. In that case, the first column of the table is the duration. So it's very simple. And then the rate, which is the interest rate expressed in percentages, are written across. So if let's say you are reading from amortization table and you want the rate of 5% for 6 years. You only go to the column under the years column, and then you look for 6. So, and then you read 6 under 5. So you get the figure. That's all. Then you come and put it there. So that is also acceptable. Okay, so you can either compute it or you can just read it from table. That's also allowed. Okay. So when you talk about sinking fund, it's about paying into a fund. You know, we have a sinking fund. Yes, that monies are paid in. So I'll just rub a bit clean, and then so we rely on 2 formulas for the sinking fund. So have a little patience. These things require a lot of patience. Just rub. Finish soon in a moment. So we're going very soon. So the financial math actually is in 2 parts. The first part is what we are ending today. So the second part will be for investment appraisal techniques, where we use financial mathematics tools such as net present value, NPV, internal rate of return, IRR, account payback method, accounting rate of return, profitability index, and so on. That will be our next topic. Then we look at probability theory. I think probably that will be the last topic. I don't know whether you have statistics. Otherwise, check if you have something on statistics. So I'm almost done. Writing is not easy, so this time I will only do down the formula and then show you how to go about it. Then we look at the frequency of compounding. Okay, so for sinking fund, we have arrears, and its S will be equal to where S is the sinking fund. So all the money that will be paid into the fund, the total amount is standing for the S. So into brackets 1 plus R raised to N, or raised to N, where N is the duration minus 1, and then all over what? R. So this is the sinking fund formula for arrears. If you want the sinking fund formula for advance, where you are paying the money at the beginning of the period. Now, I'm saying period because it's not always that to be yearly. It can be monthly, So if it is monthly, then at the beginning will be what? 1st January, 1st February, 1st March, 1st April, and so on. If it's at the end of every month, then, oh, sorry, this one, I should have multiplied it. That's I'm writing for the advance. So let me, and a period can also be, let's say, quarterly. We know that quarterly is, so this is an installment. Quarterly is what? Every 3 months. So 1 plus R will come. Okay, so the whole thing will be multiplied by 1 plus 1 plus R, all raised to what? N, and then minus 1 over R. Pardon me for. Okay, so that's the difference between the arrears and advance. Okay, so you can be asked to compute for S. You can be asked to compute for small a, right? You can also be asked to compute for R, but you can read the value of R from the table that is using the rate. Sorry, you can read the value of all this in the square bracket. That's the annuity factor from table by using R and N, where R is the rate and N is the duration. Okay, so let's go to the slides. Wow, what is that? So when we go to the slides, then we have sinking fund. And as I've explained, this is all that you need. For example, when a series of uniform payments are made into a fund that pays interest at high percent per period, they accumulate to a total capital in the future. And that's the explanation I've given. So when you go through the slides, you get everything. So let's look at this example. Now, this example, you are borrowing 46,000. You see, but the interest on this fund is 15% per annum. So that is a cost of capital you are paying. So the cost you are incurring for acquiring 46,000. But you see, normally questions like this suggest that you are going to make a one lump sum payment. You are not, that is, the repayment of the 46,000 will not be spread over a period. But then you are taking the money for whatever duration. The duration here is 5 years. So the 46,000 will be with you for the whole 5 years. So at the end of the 5th year, you are supposed to pay this 46,000 plus the accrued interest. So you can see that this one is a single sum of money that is going to be with you. So you need to determine the value of the loan at the end of this 5 years by using that simple future value formula. So for example, if you want to find the value of the loan at the end of the 6th year, then here your principal is 46,000. So P is 46,000. 46,000. 46,000. Your rate of interest is 15%, sorry, 15%. So that would be 0.15. So 0.15. And then your duration N is 5 years. So 5 years. 5 years, okay. So here, to find the value of the money that you be owing, that is amount owing, will be equal to P into bracket 1 plus what? R all raised to what? N. Write my R one well because okay, so 1 plus R raised to N. When you substitute, so you get what? 46,000. That's the principal. So substitute for P. So 46,000 will be equal to, oh sorry, 46,000 into bracket, 46,000 into bracket 1 plus 0.15, so that will be 1.15. 1.15 all raised to what? 5. So when you compute this, you're going to get a total amount of 92,000 522. Let me check. So 1.05, sorry, 1.115 all raised to 5 times 46,000. Okay. Okay, so 1.115 raised to 5 times 46,000. Let me see, what is the interest on the loan? Let me check. So that is it. So my calculator is not giving me. One point one. Oh, okay, it's 1.15. Sorry. Okay, so let's go back to our slide. So 1.15. 1.15 raised to 5 times 46,000. So that will be 92,522.43. So 0.43. Now let's look at the question again. So now it means that at the end of the 5 years, this is the money you are supposed to pay to the whether your bankers or wherever you got the loan from. But the question is saying that you have decided to set aside equal amount and invest in a fund, which that fund is paying you an interest of 11.25% per annum. You see, and the idea is that you are setting these monies into that fund so that by the end of the 5th year, that balance in the account will be exactly the 92.522. So that you are using that money to set up the loan. That's the whole idea here. Let me write this my too well. So because you are putting the monies aside for the purpose of raising a capital, which will be equal to the 92.522. Sorry, 92,522.43 to pay off this money, then it is a sinking fund. You see, so let's look at the question. So the question is saying that the debt will be discharged. You see, so that is a single payment. It is not spread over a period where you are to make equal installments as it is in amortization. No, but that is a single sum of payment of the balance, which will be 92,522 0.43 at the end of the 5th year. So the debt will be discharged at the end of 5 years with regular annual equal payment into a sinking fund, which pays 11.25% per year. Okay, so calculate the annual payment into the fund and then construct a sinking fund schedule, assuming the first payment into the fund is made at the end of the year. So you see, your payment is in arrears. If you say that assuming the payments are made at the beginning of the year, then the payment will be what? In advance. So in that case, the sinking fund formula to be quoted will be this one. Oh, why? Why are the things? So in that case, the sinking fund formula to be quoted will be this one after you have found the future amount that you'll be owing. But because it is in arrears, then we have to use this one. Okay, so here, the S, which is the total amount you'll be owing, will be equal to the total amount in the sinking fund, assuming you make the equal installment. So that will be equal to 92,522.43. 0.43. But the interest on the sinking fund is 11.25%. Take note. And not the 15%. And then the duration is the same as that of the future amount. So the duration is 5 years. So that, and then in this formula, you see you have to look for what? A, small a, which will be the installment into the fund. So small a is what we don't know. So that's a question mark. So when you substitute and you calculate, you're going to get so 1.1125, right, raised to 5. Okay, and then divided by 0.1125. Okay, so when you calculate, you substitute for everything in the box and you calculate. You're going to get 92. You repeat your 92,522.43 be equal to A, all multiplied by 15.1477. So this will be the annuity factor, which you can also read it from the annuity tables. So 15.1477. Okay, like that. So that A will be what? 92,522.43 divided by 15,000. So 92,522.43 divided by that will be 6108. Okay, so let me see whether so I think I didn't. Let me check my calculation. 14782. I think I didn't do the right computation. So 1.1125 raised to 5. Okay, so divided by 0.1125. So 92,522.43 Oh, sorry, I didn't subtract the one. So it is 1.1125 raised to 5. I don't know what is happening. So less 1, we have to subtract the 1. Okay. So minus 1 all divided by 0.1125. So that will give me 6 points. Okay, so this is incorrect, right? You make the change. So that will be 6. Yes, 6 points. So this will be 6 points. Okay, so 6.258. So 6.258. Okay, so 92552.43. So that'll be 14,787. So 14,787.4690. So 4690. Okay, so it means that you need to set aside 14,787.46 every year at the end of every year for 5 years. So by the end of the 5th year, this fund that you are making 14,787, it will grow to the 92,522 points. Remember that this 14,000, if you just multiply by 5, you won't get the 92,500 because it is earning an interest of 11.25%. So if you want to construct the sinking fund schedule, then this is how it will be. You first of all, you need to construct the schedule to show the growth of the loan. So here you have the duration. Okay, let's say the duration is here. So principal, interest, and then balance. This is for the growth of the loan. Then the sinking fund schedule is in arrears. So we have the table for arrears and the table for advance, right? Because you are paying at the end of every year. So what it means is that what you have paid in the first year will not attract any interest. Okay, let's go to the slide so that we just look at what the slide have done. Okay, so that's a figure. But when you look at the schedule, you see, here they didn't do for the growth of the fund, but you must do that as well. So that at the end of the day, the fund will be the 92,552.43, and then your sinking fund also. So this is a period 1 to 5. Total amount in fund at the beginning of period. Because at the beginning of the period, you are not paying. You wait to the end year. The year ends before you make your payment. So you see, the annual payment here is the 14,782. So you are making these equal payments into the fund for 5 years. So it means at the end of the first year, your balance will be what you have paid because you are paying on 31st December. So this will not attract any interest in the first year. That will be the opening balance beginning second year. And this money will lie in the account for the 12 months. So by 31st December, the interest will be this, 1663.05. And then remember that you are making this payment every year. So it means at the end of the first year, you have your previous payment, which is the 14787, plus the interest. And then plus another installment, yeah, you are making 14782, right? So the total amount in your fund will be what? 3122.8.41. So that will continue to the end of the 5th year. And that will be your sinking fund schedule. Okay. Right. So let's also go back to our slide. We now want to talk about where we have multiple compounding, where the interest, we know that we normally calculate interest on yearly basis. When you go to the bank, the interest that are displayed, they are all per annum. But we have cases where we have multiple compounding in a year. For example, if the interest is calculated every month, then because we have 12 months in the year, the frequency of compounding will be what? 12. Again, if the interest is calculated every quarter, how many quarters do we have in a year? That is 4. So it means that by the time the year ends, we would have compounded the interest 4 times. So the frequency of compounding is what? 4. If the interest is calculated every 6 months, so semi-annual basis, then that means that we have 2 6 months in a year. So by the time the year ends, we will have compounded the interest twice. So the frequency of compounding here will be what? 2. And it follows like that. Assuming the interest is calculated every 4 months. How many 4 months do we have in a year? 3. You see, so by the time the year ends, we would have calculated the interest 3 times. Okay. So that is what we are calling the frequency of what? Compounding or multiple compounding. Okay. Now, the interest rate, which is normally stated per annum, is what we call the nominal interest rate. The nominal interest rate. So when this rate is subject to multiple compounding, then the nominal one appears not to be effective if you are using it to compute your interest. So what we need to do is to find what we call the effective annual interest rate, the one that is what? Effective on annual basis. So what it means is that if an interest rate, that is a nominal interest rate, is compounded multiple times, then what will be effective is the effective annual interest rate, which we denote as IEFF. I'm sure you follow. Okay. So IEFF. Let me rub my things quickly. All right, so just for a moment. Let me just copy. Okay, so we have IEFF. IEFF, that is the effective annual rate. It's a very simple formula, and that is giving us R over F, all minus 1. And then, oh, it's wrong. My formula is not correct. Let me write it wrong. It's 1 minus R over F. 1 minus 1 plus R over F. So it's 1 minus into brackets 1 plus R over F sorry, it's rather appear to have forgotten my formula. Don't worry, it's rather one. It's rather 1 plus R over F, all raised to F, and not N. So it's raised to the frequency, and then you subtract 1. So this is the formula. So if, for example, you are given the nominal rate of, let's say, 10%, 10%, that is the nominal rate, and it's 10% per annum. But this one is compounded semi-annual. It means your F, the F stands for the frequency of compounding, so F will be 2. So what will be the IEFF? Now, if F is 2, then your IEFF will be 1 plus. So 1 plus 10 over 2. We divide the rate by the frequency of compounding. Raised to what? 2. And then less 1. So what do you get? Remember, the 10 is a percentage. So 1 plus 0.05, because 10% over 2 will be 5%, and 5% will be 0.05 all square. And then let's 1. So that you have 1.05 all square, and then minus 1. So this will give you 1.05 square. 1.05 square. 1.1025 all minus 1, which is 0.1025. If you multiply by 100%, then it will be 10.25%. Now remember that, so 10.25%. Remember that the effective annual interest rate is higher than the nominal interest rate. So for example, this one we're giving 10% as a nominal interest rate. What it means is that because the rate is compounded semi-annually, if you use the 10% to compute it annually, because somebody will say that, but if I compute the interest twice a year, is it not by using the 5% twice a year? Is it not the same as using 10% once a year? You see, that doesn't hold. What it means is that what is effective, if you still want to calculate the interest once in a year, then it's 10.25% and not the 10%. You see, so whenever, it's very simple, whenever you are given, you are asked to compound the rate of interest a number of times. And in fact, a number of times here suggests that if it is semi-annually, that's the lowest. So that will be twice a year. Or they say 6 monthly, then you should know that your F will be 2. So all you have to do is to introduce your F in the formula, which of the formulas we are using, whether it's a future value formula or annuity formula, such as amortization or sinking fund. All you need to do is to introduce your F, that is, you divide the rate by the frequency. Let me do an example here. Assuming the rate is 20% per annum, That is a nominal interest rate. And we are to find the future value of 10,000 cedis. But the rate is compounded quarterly. See, the rate is compounded quarterly. Then we need to divide the 20% by 4 and use the formula. So as for the formula, it doesn't change. The only changes that will take place is the division of the rate by the frequency. That's all. So it is not anything that should be confused. For example, I'm saying that the principal is 10,000, right? So P is 10,000. P is 10,000. So then your R is 20%. That's the rate of interest, is 20%. 20%. And then your N, the duration of the loan, of the investment is, let's say, 5 years. But you are told that this rate of 20% is compounded quarterly. So in that case, your F will be 4. If you are told that it's compounded semi-annually, then your F will be 2 because we have only 6 months in the year. If you are told that the rate is compounded monthly, then your F will be 12 because there are 12 months in the year, and so on. So in this case, you are only using this formula. The future amount, you want to find the future amount of this single bulk sum of payments. You want to invest this money into an account for 5 years. We suggest that there will be no additions and there will be no withdrawals. See, so the formula will change like this. You know that the original formula used to be 1 plus R. But because the R is compounded a number of times, then we have to divide the R by that number of times. And again, your N will not be just what? N, like this. Because assuming we are compounding this for 5 years, the duration of the investment is 5 years. And we are compounding it 4 times each year. So if 4 times each year, and then for 5 years, so by the end of the 5th year, how many times do you think the rate have been compounded? So that will be the 5 times the frequency. You see, so here, just multiply the duration by the frequency. So whenever you are told that the investment is compounded a number of times, then these are the 2 things you have to do. First, divide the rate by the frequency. And then second, multiply the duration by the frequency. So this will be just the 10,000. So the 10,000, then 1 plus, is it the rate is what? 20%. But then we have to divide the 20 by the frequency because we are told that we compound it quarterly. And we have 4 quarters in a year. Okay, and then the duration is 5 by 4, so that will be 20. So by the end of the 5th year, the rate might have been compounded how many times? 20 times. You see, so when you have done all this, 10,000, you know that 20 over 4 is 5. So remember, this is in percentage. So let me put the percentage. Okay. And 5% will be 0.05 plus 1 will be 1.05 raised to 20. Okay. So that you have 1.05 raised to 20 will be 2.65. Okay, so times 10,000. That will be 26,000. I'm not sure. 1.05 raised to 20. Okay, so times 10,000. Okay, so that will be 26,005 532. Now take note that when the rate is compounded, or the higher the frequency of compounding, the higher the returns. So that will be 26,532. You see, so when you are going for a loan and the loan is compounded monthly, they say most of the microfinance, and these days they have even been chasing us that a loan and the rate is 5% per annum. 5% per month. When you hear the 5%, you think it's small, but it's per month. So that is expensive. What it means is that the annual rate is 60%. You see? Okay, so normally when you have calculated you are given this multiple component, then you'll be asked to find the effective annual interest rate. So here the effective annual interest rate will just be 1 plus 5%. So 1 plus 0.05. 1 plus 0.05 all raised to what? 4. Then minus 1. So 1.05 raised to 4. And that will be 21.55%. You see, so instead of using 5%, so instead of using the 20% annually, because it is compounded quarterly, then you cannot, if you use the 20%, it will be wrong if you want to compute the interest annually. So if you want to compute the interest annually, then it will be 22.5%. And you can see that if you use the 21.5%, not 22, so 21.5%, okay, so 21. So if you use the 21.5% to find the future amount, you get the same thing. So you see, that will be 26,532 as we got it initially. But if you use the 20% for 5 years, you will not get to this figure. You see, so that is what you should take note. Okay, so let's go to our slide. I think we are getting to the end of it, and then we'll see. Okay, so that is all that is about nominal and what? Effective interest rate. So you only have to read. That's what I've explained. So I'm skipping all this. So you see, that's the formula. 1 plus R over M, where M is the frequency of compounding. Okay, so this is an example. The nominal rate is 12%. And then it's computed every month. So you see, because we have 12 months in the year, your M is 12. So that'll be 12% over 12, and that'll be 1%. What it means is that we are using 1% every month. So the rate will be 1 plus 0.01 raised to 12 over minus 1. That will be 12.68%. So if you don't want to calculate it every month and you want to calculate it annually, then it's 12.68%. Okay, and this is another example, which is also the same principle. Okay, so this is semi-annual payment, that is 6 months. So R is, if the rate is 7%, then the R over 2 will be 3.5%. So we'll get 7.1%. So one of your clients has asked for your advice concerning 100 million, which he wishes to invest for 5 years. So you want to invest 100 million, and it's about one single payment that you are making into an account. You want to deposit this money into an account and forget about it for the next 5 years. Now, there are two alternative investments. The two alternative investments are to use a bank account where the 36% per year rate is compounded monthly. So this one, the nominal rate is 36%, but the multiple compounding is every month. So you are going to divide the 36 by 12, and that will be 3% every month. Or you have a savings fund where the 40% per year rate is compounded annually. So this one is compounding is what? On annual basis. So you are not to divide it by anything. The only thing you can do is to divide by 1, which will give the same 40. So you should calculate the size of each fund at the end of 5 years, and then calculate the effective annual interest rate of the bank account, and then advise your client. Okay. So you can see that for the first one, you divide your nominal rate of 36% by the frequency. So 36 over 12, that's 3%. So when you calculate the effective annual interest rate, you get 42.58%. Okay, so the bank account will give you 589,160, and the savings fund will give you 537. So you can see that the bank account is higher than the savings fund. So that is the advice you give to your clients. And the effective annual interest rate is 42.58%. Okay, so we now come to what we call continuous compounding. So when interest is compounded continuously, you see, when the future value of a current amount P over T years periods, over T periods is PE raised to RT, PE raised to RT. And this is giving us 1 plus IFF raised to T. That is the E raised to R is giving us 1 plus I, that is a rate, and then the effective. So if you want the effective, then it is 1 minus the E raised to R. Okay. So this is an example. So for an interest rate of 18% per year compounded continuously, calculate the effective monthly and annual interest rates. An investor requires an effective return of at least 15%. What is the minimum annual nominal rate that is acceptable for continuous compounding? So here, the nominal rate is 18%. So that will be, because it's monthly, they said they want the monthly effective. What is effective on monthly basis? So that will be 18 over 12, and that will give you 0.015. It is 1.5%, right? So when you convert to decimal, that's over 100, will give you 0.015. Then the effective monthly is what? Just substitute into the formula. We know that IEFF is giving us E raised to R minus S. So the rate is the 0.015. You know your E in the form in the calculator. You go to second function and then you press IN. So second function shift and then IN. It will give you, if you are using this calculator, then E, you must put something to the box. You see, so it should be 1. But because the R is 0.015, you press E and then 0.015, right? And that will give you 1.01511. So when you less 1 from it, then you get, and then when you multiply by 100, you get 1.511%, right? So similarly, the effective annual rate using the per annum year. As for the per annum year, then it is the 18%, which is the per annum. So that will be 1 minus, sorry, ER minus, so second function in, and then 0.18. That will give you 1.1972. So if you less than 1, then you have 0.1972 times 100 will give you 19.72%. Now take note that for every effective rate that we calculate, the figure must be higher than the nominal rate. So that must be a check. So you see this one, the nominal rate was 18%. but the effective is what? 19.72%. So take note. So continuous compounding, the third one, this is how you go about it. Another example. Honestly, I'm tired, so you can go through the rates, right? This is also another example. Inflation rates. Okay. So we'll end here. We'll continue next time. So our next topic will be for the investment appraisal techniques. So have a nice day and take care. Okay.